Salut à tous les profs du Québec. J'ai un service à vous demander. Pourriez-vous m'aider avec une leçon que j'aimerais donner le temps prochain? J'aimerais que mes élèves mesurent notre planète. Mais nous avons besoin de votre aide. Ce dont nous avons besoin est très simple. Je vais vous expliquer plus en détail, mais tout ce que je demande, c'est que vous mesuriez la longueur d'une ombre le premier jour de l'été. Je m'appelle David Strasburger. J'enseigne la physique et l'astronomie à la Lawrence Academy de Groton dans le Massachusetts. Comme vous pouvez l'entendre par mon accent, je ne parle que le français d'un petit écolier américain. Je m'excuse, mais je vais continuer en anglais. Here's what I want to do with my students. I would like them to measure the globe, but without leaving the school. And in order to do this, we need help from people to the north of us. And that means you. And all I'm asking is if you would be willing, you personally would be willing to go out on the first day of summer and measure how long a shadow is. I'll explain more in detail. The specifics of what I would ask you to do, the favor is to go out on the summer solstice. That's either June 20th or June 21st. This year it happens that the astronomical solstice falls right very close to midnight, so it doesn't really matter whether you do it on the 20th or the 21st. But you would go out at the moment when the sun is highest in the sky, which is on that day is going to be about 12:45 or 12:46 in the afternoon, and measure how long a shadow is, any shadow that is cast on level ground, and measure the height of whatever it is that's casting the shadow. And that when you do that you make a video of yourself doing it so that students can literally see the measurement. So, it would be lay a ruler down next to the shadow, take your cell phone, take a video, maybe first introduce yourself and tell us where you are. Let me explain why I'm asking this. I want my astronomy students to have the experience of measuring something that they can't actually reach with their own hands, because that's really what astronomy is all about. To do this with simple tools and just a little bit of geometry, we're going to use the method of Eratosthenes from over 2,000 years ago. In Egypt in the 3rd century BCE, Eratosthenes was able to measure the circumference of the Earth with an accuracy of about 3%, which is pretty amazing. And if you want to know more, you can hang on to the end of the video. But essentially, in order to do this project, we need the following things. We need people who are directly north or south of us, and there aren't that many people south of us. So we need people who are directly to the north of us. We need a pretty good distance, like minimum 200 kilometers. And we need people who are between longitude, sort of near longitude 70 degrees, between 71 and 72. So the perfect place is Quebec City. Sherbrooke would be good. Saguenay would be fabulous. I've never been to Saguenay. I hear the cider is excellent. Or Qutialuk in Nineveh. If you know somebody in Nineveh who can contact the school in Qutialuk, I have been trying to reach you, and I would love to talk to you because you are as far north from us as you can get. If you'd be willing to help with us, you can email me. I'll put my address right here. Or you can just comment on this video and I'll reply with some details. I could give you a few technical details on how to make your measurement especially good and useful to us. Seriously, I would be so grateful if you'd be willing to do this. We will thank you publicly, and you can stop watching now. and merci mille fois. However, if this project is interesting to you, and you could keep watching for one of two reasons. Reason number one is this sounds like a project that's interesting enough to you that you would like to do it with your own students. Then hang on. Or if you're not planning on doing this, but you're curious about how it works, hang on and watch the rest of the video. So if this is something you'd be interested in doing with your own students and you're wondering whether it would be appropriate, I think this is something that you could do with elementary school students or middle school students or high school students. And it doesn't require very much math. The math necessary is you need to be able to multiply, you need to be able to divide, and you need to be able to read and measure an angle with a protractor. I think this is something that could be fun with a geography class or a mathematics class, or, I'm going to do it in astronomy. You could do it in any science class. Just if this sounded like an interesting activity one day for your students, let's talk and we can share information. So the method of Eratosthenes is one that you can look up, and it'll probably be a better explanation than the one I'll give. But in short, Eratosthenes was the chief librarian at Alexandria. And he knew that on the first day of summer that there was a well in Syene that which is now currently called Aswan, and that on the first day of summer that the sun would shine directly down this well. And that's important because that means that the sun is perfectly overhead, right? The well goes straight down. The only way the sun's going to shine straight down is, if the sun is perfectly overhead. And he knew that in Alexandria he was 500 stadia away from Syene. A stadion was a Greek measurement of distance that I think is about 155 or 160 meters long. And without going into too much detail, what he did in Alexandria was he set up a tall pole whose height he knew. And at noon on the first day of summer, he measured the length of the shadow cast by the pole. And if you know the height of the pole and the length of the shadow, you can figure out what is the angle that the sun makes to the top of the pole. What's that angle? And if you do a little bit of geometry, that is also the angle difference between Alexandria and Syene. That is how far up from Syene in latitude angle you are. And he said, well, if I know the angle, that is some portion of a whole circle. So if you know the actual distance between Alexandria and Syene, then that distance must be the same portion of the distance all the way around the Earth. And that's the method of Eratosthenes. And again, if this is something you're interested in doing with your own students, you can look this up, or I would be delighted to talk with you some more about it, and we can work out how it might look for our kids. Anyway, thank you so much, and I would love to talk to you.